Now, I mentioned that today's way of factoring so incredibly easy. So incredibly easy. Today we're going to be doing what's called factoring differences of squares. So if we go back to the factor flowchart. Now, remember, and I've said this I think already 3 times today, because you can count how many times I've said this before today, factoring is the opposite of FOILing. And we just talked about, before you guys took that little homework quiz, that usually when you FOIL something out, you get the F, the L, the O, and I combined together, so you get 3 terms, right? What we're going to be doing today is whenever we count the terms, there's only going to be 2 terms. 2 terms. Because if you remember, we spent the whole first half of this chapter multiplying, FOILing in the box method. Sometimes there was this special case where when you FOIL something out, you don't end up with 3 terms. You get the F and the L, but the O and the I are always going to cancel out, and that's what we're going to look at here. So, if you remember these ones, if I have x plus 4 times x minus 4, the criteria here, and these ones were super, super easy to multiply, which is nice because it means they're super, super easy to factor. Well, if we FOIL this out, and then we'll kind of talk about the pattern, okay, the F is x times x, which is x squared. The O would be x times negative 4, which is a negative 4x. The I is 4 times x, or a positive 4x. And then the L, 4 times negative 4, is negative 16. And I kind of already mentioned this. Usually, you get your F, and you get your L. Usually, the O and I combine together to give you that middle term. But what happens here, and what happens every single time when you multiply the exact same thing, the only thing that's different is the signs, that middle term is going to cancel out every single time. So since these were so easy to FOIL, because all you had to do was the F and the L, they're so easy to factor, okay? So to go through these, all right, the first thing, and we're really going to start hitting this hard today, the first thing you want to do, and a lot of times it's not going to happen, but whenever it does happen, you definitely need to know. You need to factor out the greatest common factor. So if you look at this, x squared minus 9, if they had something in common, you would need to factor it out. Now, x squared and 9, they don't have anything in common. So we would jump to this one. You'd say, is it a difference of squares? We'll come back to why it has to be a difference of squares in just a second. If it is, you're going to factor it. Now, although this is a different type of factoring, you already know what your answer looks like. Because for every single factoring problem, the answer to a factoring problem is a FOILing problem. What we're trying to figure out here is, what would I FOIL out to give you that back? We're kind of thinking ahead here. I FOILed something out, and I only have 2 terms. That O and I, they're gone. The O and I canceled out. So what happens here is you just have to figure out what the F is and the L is. So for the F, you would do x times x. For the L, negative 9. What times itself gives you negative 9? Plus 3 and a minus 3. These are so easy to factor, guys. Now, let's come back to this right here. For it to fit this pattern, there's 2 things that it has to do. And this is what it says in the factor flow chart. If there's 2 terms, if you are going to factor this way, it has to be a difference of squares. So first thing, it has to be subtraction. Because remember, the whole reason the O and I canceled out is because one was a positive and one was a negative, right? And in order for one to be a positive and one to be a negative, that L is always going to be a negative, always. So it has to be subtraction, has to be. And the other criteria, when we multiply these, remember how it has to be the exact same thing in both sets of parentheses? It had to be x plus 3x minus 3, x plus 4x minus 4. 5x minus 2 and 5x plus 2. It had to be the exact same thing in both sets of parentheses. So when you find your f, you are multiplying the same thing by itself. It has to be something squared. So x squared, 3 squared. It has to be a difference of squares. Okay? Let's jump to this one here. Okay, if we did 4x squared minus 25, first thing, we want to check for greatest common factor. Now, I might need to take an extra second for this one, is that number. So 4 and 25, is there anything you can divide out of 4 and 25? Okay, you need to check. Now, as soon as you see that there's two terms, remember, we're trying to figure out what would I FOIL out. If I FOIL something out, and I only get two terms back, it means that I only have the F and the L. The only I are going to cancel out, which means it has to be a difference of squares. What it means by squares is you have to have the same thing in the front of the parentheses. What times itself would give me 4x squared? 2x times 2x. Remember, it also has to be the same thing at the end of the parentheses. What times itself gives me 25? 5. So that would be a plus 5 and a minus 5. See how easy these are to factor? These are super, super easy to factor. Okay? All right, let's get this loaded into your notebook. This should be page 27. This is section 8.7, and it is difference of squares. Okay, so I'm going to go through the same steps for every single one of these because, like at the very, very beginning, I mentioned that I think whenever we're just doing like this type of factoring, it's super, super easy. And even last week, although it wasn't quite as easy as what we're doing today, if we knew what type of factoring we were supposed to do, it was a little more straightforward. I know how to factor these ones. I know how to factor these ones. I know how to factor these ones. When you guys get to your test that you guys are going to take next Wednesday, all of the different types of factoring is going to be thrown together, and you are going to have to know which of these methods to use. So I'm going to kind of talk you through some things to help you decide. So number one is we have x squared minus 49. So what I'm going to be doing is I'm going to be kind of talking through that factor flow chart, which if you know how to use it, can be super useful when it comes to a test. Okay? So if you talk through that factor flow chart, the first thing we always need to check for is the greatest common factor. So x squared and 49, they don't have anything in common. Now the next thing in your factor flow chart says use count the terms. Notice this is different than what we did yesterday. There's only two terms here, x squared and a minus 49. If there's two terms, your factor flow chart, there's only one way you can factor two terms. It has to be a difference of squares, x squared and 7 squared. It works, okay? So we can go ahead and factor. Now remember, I already know what my answer is going to look like. And keep in mind that this is the answer to a FOILing problem. And if I FOIL something out and only get two terms, that's my F, that's my L. So what times what gives me x squared? X times x. What times what gives me a negative 49? 7 times 7. What would the signs have to be? They have to be different. They have to be different. Because if the O and I are going to cancel out, they have to have opposite signs. Okay? Number 2, let's do p squared minus 64. Okay, once again, if we talk through that factor flow chart, we should check for greatest common factor. P squared 64, they don't have anything in common. If I have two terms, okay, if I only have two terms, it means that when I FOIL this out, I just get my F and my L. Okay, well, what times what gives me p squared? P squared? P times p, what times what gives me negative 64? Plus 8 minus 8. That's this factor. See how easy that is today? Super easy. Okay? Okay, number 3. If we have 9 minus y squared. If we go through the same steps, I check for greatest common factor, 9 and y squared. They don't have anything in common. I have two terms, which means when I FOILed this out, in this order, I get my F and my L. So since the 9 is your F, it means that when I multiply the first terms together, I get 9. So what times what gives me 9? 3. That 3 has to go in the front. Okay. What times what gives me a negative y squared? It's just a plus y and a minus y. Same thing. Just the y's at the end. Okay, number 4. Well, if we have 4a squared minus 25. We're kind of talk through the same thing. I check for greatest common factor. They don't have anything in common. I have two terms, which means I just have to figure out the f and the l. What times what gives me 4a squared? 2a times 2a. What times what gives me a negative 25? A plus 5 and a minus 5. And remember, the signs have to be different, right? Because the whole point here is that I don't have a middle term. The middle term cancel out, so the signs have to be different. Okay, number 5. 16a squared minus 81. You always want to check for greatest common factor. Do 16 and 81. Anything in common? That's why it's 16 out of 81. We want to check. There's not going to be anything there. So let's go ahead and let's factor it. To get my f, what times what gives me 16a squared? 4a times 4a. To get my L, what times what gives me a negative 81? Plus 9 and a minus 9. Okay, what about this one? What if we do 64 n squared minus 1? Okay, greatest common factor. 1, right? If you remember 1, there's not going to be greatest common factor here. So if I get ready to factor this one, to get my f, what times what gives me 64 n squared? 8. 8n times 8n. What times what gives me a negative 1? Yeah, plus 1, minus 1. You guys believe me that I said it's a really easy factor? Caitlin?
So like, does it have to be a number that, like, does it have to be the same number? Or like 5 to 8 and 16, does it have to be like 4 and 4, or could it be like 8 and 2?
Great question. Great question. So let's say I did want to do 8a and 2a, and then maybe if I still did a plus 9 minus 9. Okay? This would give me 16a squared. This would give me minus 81. Well, look at your O and your I. This would give you negative 72a. And that would give you plus 18a. See how they don't cancel out? So it does have to be the same number. It's a great question. I'm glad you mentioned that. So yes, it does need to be the same number. Yes.
What happens if they actually do
Another great question. We're actually going to do that next. So let's do that one. Okay, so number 7. What if I have 8d squared minus 8? Now, oftentimes what happens with these ones is students forget that we're supposed to check for greatest common factor, but I kind of already hinted to you this is going to have a greatest common factor. Because if you try to just say, okay, what times what gives me 8d squared? There isn't anything, right? 4 times 4 would give you 16. If there isn't anything. Because there is a greatest common factor here. And they're in common. 8. So you're going to factor it out. Now remember, how you factor this out, you're going to write the greatest common factor on the outside and open a set of parentheses. And then redistribute the 8. 8 times what? 1d squared or just d squared. Either way is fine. 8 times what gives me negative 8? Negative 1. Now here's the thing. If you factor out an 8 in the beginning, your answer has to have the 8 out front. That's the only way this changes. Because now you're going to look at this d squared minus 1 and factor that. The d squared is your f. What times what gives you d squared? 8 times 1. Yep. And it would have to be there. I think that's a lot of things that students do too, is they think it's maybe a 0, but you have to have that 1 there. Okay, so what times what gives me d squared? Times d. What times what gives me negative 1? Plus 1 minus 1. So your answer is 8 times d plus 1 times d minus 1. Okay, let's do one more of those. Okay, number 8. So we have 24e squared minus 54. Now this, once again, if you try to just jump to factoring this and say, okay, what times what gives me 24e squared, with the understanding that it has to be the same number, there's nothing squared that gives you 24. So that should kind of give you an indication that there is a greatest common factor here. 24 and 54. You cannot divide 8 out of 54. A little bit smaller than that. A little bit bigger than that. It's going to be 6. They have a 6 in common. Remember, you will find the greatest common factor, so the biggest number. So, if I factor out a 6, when you factor out a 6, if this is easier to think about, it's like you're dividing each of these by 6. So this would give you 4e squared, and this would give you a minus 9. Remember, if you factor out a 6 in the beginning, your answer should have a 6 out front. Then you're just going to look at this. What times itself gives you 4e squared? 2e times 2e. What times itself gives me negative 9? Plus 3.